Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of JEE Main, we're going to be looking at previous year questions of mathematics in various engineering exams in India. Today we're dealing with a very important chapter. The name of this chapter is Differential Equations. There are many questions asked in differential equations. Today we're going to be having a look at some of them, which are very important. So without further ado, let's look at our first question of this episode. So here it's given that y equals x plus under root of 1 plus x squared, the whole raised to n. Then find out the value of the expression for 1 plus x squared times d squared y by dx squared plus x times dy by dx is equal to what expression? So you need to find out the expression which is equal to the given question. So how do we solve this question? Well, first of all, you know that y equals this expression. So the first thing you need to do is to differentiate with respect to x. When you differentiate with respect to x, the left hand side will become dy by dx, and the right hand side will use the formula for d by dx of box raised to n. That will be equal to n box raised to n minus 1 times d by dx of box. Feeling confused? Let's apply it here. So here it's a bracket and then raised to n, so we'll write n times the bracket, which is x plus under root of 1 plus x squared, and we will raise it to the power n minus 1, and then times d by dx of the bracket, which in this case is x plus under root of 1 plus x squared. So let's write dy by dx as y1, first differential, and over here you will be having n times x plus under root of 1 plus x squared whole raised to n minus 1 times d by dx of x is 1 plus d by dx of anything in a root will be written as 1 by 2 times that same root, 1 by 2 root of 1 plus x squared, and then you will differentiate whatever is inside the root, which in this case is 1 plus x squared. So we will be writing y1 equals n times x plus 1 plus x squared under root, and the bracket is raised to n minus 1 times 1 plus 1 by 2 into under root of 1 plus x squared, and over here you have d by dx of 1 plus x squared. That will be equal to 2x. So 2 and 2 gets cancelled, so therefore you will have n times x plus under root of 1 plus x squared whole raised to n minus 1 times 1 plus x divided by under root of 1 plus x squared. So we will take LCM inside that square bracket, so now y1 will be equal to n times, inside bracket you will have x plus under root of 1 plus x squared, the bracket is raised to n minus 1 times under root of 1 plus x squared plus x divided by under root of 1 plus x squared. This is the square bracket. So as you can see, x plus 1 under root of 1 plus x squared raised to n minus 1 times the same term raised to 1. So when you're multiplying the same quantity with different powers, you just add the powers. So in this case it's n minus 1 plus 1. So therefore you get n raised to x plus under root of 1 plus x squared, the whole raised to n, divided by under root of 1 plus x squared. So this is the value of y1. Now notice that the value of y is the bracket raised to n. So therefore we will substitute the value of y here. So y1 equals ny divided by under root of 1 plus x squared. Now we just take under root of 1 plus x squared to the left hand side. So therefore ny is equal to under root of 1 plus x squared times y1. We'll just write that as dy by dx, because from here onwards we will have to do another differentiation. But before that, it's good to take the square of this equation. So therefore you have n squared y squared equals 1 plus x squared times dy by dx the whole squared. Now let's differentiate with respect to x again. So on differentiating with respect to x, you will now get second differentials. So the left hand side will be n squared y squared, so it will be n squared is constant, and then d by dx of y squared is 2y times dy by dx. And on the right hand side, you will basically have 1 plus x squared times dy by dx the whole squared. So therefore we will have to first write dy by dx the whole square times the differential of 1 plus x squared, which is 2x, plus the differential plus 1 plus x squared times the differential of dy by dx the whole square. So that will be 2 dy by dx times d by dx of dy by dx. So the right hand side will now become 2x into dy by dx the whole squared plus 1 plus x squared times 2 into dy by dx times d square y by dx squared. So now you get a second differential. Differential of the first differential is the second differential. So now what do we do? Now what we can do is we can take 2 times dy by dx common on both sides. So when you take 2 dy by dx outside, you get n squared y on the left hand side, and on the right hand side you get 1 plus x squared into d squared y by dx squared plus x into dy by dx. Now 2 dy by dx is common, so we cancel that out. So therefore finally you get the expression 1 plus x squared times d squared y by dx squared plus x times dy by dx equals n squared y. So this left hand side was the question which we asked here. So therefore the right hand side must be the correct equation. So n squared y is the correct answer. So if you look at our question asked in 2002, the correct option here would be option A, n squared y. Let's move on to the next question. The solution of the equation d squared y by dx squared equals e raised to minus 2x is. So is it option A, option B, option C, or option D? So the first thing is to take the equation d squared y by dx squared equals e raised to minus 2x. So in this question, instead of differentiation, we have to do integration. So on integrating, the left hand side will become y1, that is first differential, so dy by dx. The right hand side is integration of e, or log. So when log or e comes in integration, we have to use certain formulae. So here we have e raised to x, So integral of e raised to x dx is equal to e raised to x divided by 1 plus a constant c. So if x was equal to 2 pi, if x was equal to 2a, then it will be e raised to 2a divided by 2 plus c. So similar problem. Here the exponent is minus 2x, so you will write e raised to minus 2x divided by minus 2 plus a constant c. This is the first differential. But we will not stop there. We will integrate it further. So on integration again, the left hand side will now become y, and the right hand side will be integral of 1 by 2 into integral of, it's basically minus, we forgot to put, we have put it here, so it's minus 1 by 2 times integral of e raised to minus 2x into dx, and then you already have a plus c, so that is integral of c as well. So integration of e again gives you minus 1 by 2 into e raised to minus 2x divided by minus 2. So that's that, and then the constant here will now become c x, because integration of a constant, so c into integration of dx will give you c of x, and then there will be an integrating constant. So here, since we can't put c, we'll just put it as d, and then we'll have to simplify here. So it is e raised to minus 2x divided by minus 2 into minus 2. That will give you 4 plus cx plus d. So therefore you will get 1 by 4 times e raised to minus 2x plus cx plus d. So this is the solution of the differential equation. And if you look at our options, you can see that option B, 1 by 4 e raised to minus 2x plus cx plus d, matches our answer. So for this question asked in 2002, the correct option is option B. Now let's look at this question. It's kind of very simple. So here you're only asked to find out the order and degree of the differential equation given. This is the simplest type of question which you get in the chapter differential equations. So it's important to know what is order and degree here. So basically the order stands for highest differential, and then the degree stands for the power to which the highest differential is raised. So this is the de facto definition for an order and a degree, and we will be able to find that out by tweaking this equation. So here the equation is 1 plus 3 dy by dx the whole raised to 2 by 3 equals 4 times d cubed y by dx cubed. That equation can be written down as 1 plus 3 times dy by dx the whole square equals 4 d cubed y by dx cubed the whole cube. So basically, since here it is 2 by 3, we intended to simplify it, and so we decided to take cube on both sides. So therefore the left hand side becomes a square and the right hand side is written in terms of a cube. Now over here, between dy by dx and d cubed y by dx, d cubed y by dx is the higher differential. This is the first differential, this is the third differential. So therefore the order here is equal to 3. That is correct. Now the right hand side is written as 4 times the third differential the whole cube. So as you can see, the highest differential here is now raised to a power of 3. So therefore the degree of this differential equation has to be equal to 3. So therefore, the correct option in this question is option C, 3, 3. So if you know what the order is and what a degree is, and if you can simplify this question as shown, then you can get this answer easily. This is one of the easiest questions asked in 2002 with respect to differential equations. Now, next question. The degree and order of the differential equation of the family of all parabolas whose axis is x-axis are respectively. So here, this question is similar to the previous question. However, we do not have the equation given to us. We need to get the equation. So here it says family of all parabolas whose axis is x-axis. So here we know that the axis of the parabola will be the x-axis. So what does that mean? It means the focus of the parabola will be equal to a comma 0. So the focus will be on the x-axis. So therefore you can write the equation y squared equals 4a times x minus k. This is the general equation for an upward parabola, a parabola that's facing upwards. So if you have the family of parabolas whose axis is the x-axis, then you can take upward and downward parabola. In order to make it upward and downward, we just put a minus k on it. So if k's value is greater than x's, then it becomes minus and so forth. So that is why we wrote the general equation y squared equals 4a times x minus k. Here k is a constant. Now what we do is we differentiate this equation with respect to x in order to make this a differential equation. So differential of y squared is 2y times dy by dx, and the differential of 4a times x minus k. So we'll just have to write this as 4ax minus 4ak. So differential of x is 1, so you have 4a times 1 minus 4ak. All of them are constants, so therefore differential of a constant is 0. So 2y times dy by dx is equal to 4a. You can just cancel the 2 here, so therefore y dy by dx equals 2a. But we will not stop here. We'll have to differentiate it again. So differentiating with respect to x, you will get the left-hand side uses the product rule, so y times d by dx of dy by dx, so that is d squared y by dx squared plus dy by dx times dy by dx the right hand side will be equal to 0. So this is a differential equation, an equation which consists of only the differentials. So we can write the left hand side as y times d squared y by dx plus dy by dx the whole squared equals 0. So over here you have a second differential, you have a first differential, and among these two differentials, the second differential is higher. So therefore the value of the order is equal to 2, and the value of the degree will be equal to 1 because it is raised to 1. So therefore the correct option for this question is option A, 1, 2. Now why is it not 2, 1? Because it says degree and order. So we have to take it as 1 and 2 instead of 2 and 1. So therefore this is incorrect. So over here in option C, the order is incorrect, and in option B, the degree is incorrect. So therefore both those options are incorrect. In option D, the order and the degree are switched, so the value of the degree is given as the order and the value of the order is given as the degree, which is again incorrect. So the right answer is option A for this question asked in 2003. This is the final question of this episode. You need to find the solution of the differential equation 1 plus y squared plus x minus e tan inverse y times dy by dx equals 0. So over here, you must note that this equation here is a linear differential equation. For a linear differential equation, it is normally represented as dy by dx plus p of x times y equals q of x, or it will be dx by dy plus p of y times x equals q of y. So basically p and q are terms which are either in x or in y depending on the differential equation. So this is the standard form of a linear differential equation, and then we have to find the solution for it. So we have the given equation 1 plus y squared plus x minus e raised to tan inverse y times dy by dx as equal to 0. So what we're going to do is we're going to convert this to a linear differential equation. So we can write 1 plus y squared as equal to minus of x minus e raised to tan inverse y times dy by dx. And you can take dy by dx to the left hand side, so you get 1 plus y squared into dx by dy. And that is equal to, on the right hand side, it will be minus x plus e raised to tan inverse y. The equation now becomes 1 plus y squared into dx by dy. Minus x is taken to the left hand side, so that becomes plus x, and that is equal to e raised to tan inverse y. So as you can see, q of x is in terms of y. We have to make this into a standard form of a linear differential equation. So dx by dy plus x divided by 1 plus y squared is equal to e raised to tan inverse y divided by 1 plus y squared. So this is our linear differential equation. So it's pivotal now to identify the constants. So p of y here is equal to 1 by 1 plus y squared, and q of y here is equal to e raised to tan inverse y divided by 1 plus y squared. So we now know the value of p and q. So how do you find the solution? The first thing to find out is integral of p with respect to y. So integral p times dy is equal to the integral of 1 by 1 plus y squared times dy. So how do we find out the answer here? Well, you can think of differentiation. If you were to differentiate tan inverse y with respect to y, you would get 1 by 1 plus y squared. This is a general formula. We just invert the formula by inverting the function. So the integral of 1 plus y squared with respect to y will now be equal to tan inverse y. The reason why we're not adding a c here is because we have to take this further. So integral p dy is equal to tan inverse of y. The second thing that we need to find out is what we call the integrating factor, or IF. So the integrating factor is usually equal to e raised to integral p dy. If it was for dy by dx, it will be e raised to integral p dx. So e raised to whatever we found in the first step is the value of the integrating factor. So in this case, that is equal to e raised to integral of 1 by 1 plus y square times dy. So e raised to tan inverse y will be the value of the integrating factor. So that is step 2. Step 3 is to write the general form of the solution. The general form of the solution to a differential equation is basically, for our type, it's basically x times the integrating factor, which is in terms of y, and the right hand side will be an integral of q, which is in terms of y, times the integrating factor, which is again in terms of y, and this is written in terms of dy, and then plus c. So now let's put in the values. So x times the integrating factor here is e raised to tan inverse of y. That is equal to the integral of q, which is e raised to tan inverse y divided by 1 plus y square, times integrating factor is e raised to tan inverse of y, and then this is divided, these are, the whole term is integrated with respect to y, and then there is a plus c. So in order to proceed further, we will just combine the right hand side. We'll make modifications on the right hand side. So x times e raised to tan inverse y will be equal to the integral of e raised to tan inverse y the whole squared divided by 1 plus y squared times dy plus c. So the numerator is in terms of x raised to a the whole raised to b, which is equal to x raised to ab form. So we will use the law of integers here on the right hand side. So therefore x times the integrating factor, that is e raised to tan inverse of y, will now be equal to the integral of e raised to 2 tan inverse of y divided by 1 plus y squared into dy plus c. So over here on the right hand side, it's best if we use substitution. So over here we will take tan inverse y as a variable, say t. So therefore the derivative dt will be equal to 1 by 1 plus y square times dy. This is basically integral calculus, which you studied in grade 12. So using substitution, we will substitute tan inverse y as t, and we will substitute the value of 1 by 1 plus y squared times dy as dt. So in this question you have e raised to 2t times dt plus c on the right hand side. And there is an integral sign as well, so don't forget it. So e raised to 2t can be written down as, integral of e raised to 2t can be written down as e raised to 2t divided by 2 and then plus c. So therefore you will get the right hand side as equal to e raised to 2 tan inverse of y divided by 2 plus c. So therefore the final equation, by taking 2 on the right hand side, will be equal to 2x into e raised to tan inverse of y will be equal to e raised to 2 tan inverse of y plus c. Now the reason why this wasn't taken to c is because c is a final constant and the value can change. We're not writing the value of c, we're just representing that there is a constant c. So therefore it does not change. So therefore the final equation here is 2x times e raised to tan inverse y equals e raised to 2 tan inverse y plus c. This is the solution to the given differential equation. So therefore, if you were to look at the options in this question, you will safely conclude that option A is the correct option. We used constant c there. Here they're using a constant k. Again, it does not matter, so therefore option A is the correct option for this question asked in 2003. So that concludes this episode of JEE Main. If you want to access more of our videos on JEE Main, you can always click the link in the description down below. For watching more of our useful and interesting content, don't forget to subscribe to our channel, that is Brain Blitz Audios. You can also hit the notifications button below the video to receive updates about our latest content. So until the next webisode, take care, stay safe, bye-bye for now.